Hi, all, let's start. Today, guys, we are going to see another topic known as GIT, and we will see GIT hub as well. Right? So, guys, let's start. Let me launch two instances. Say one is Linux, other one is Windows. Right? We are going to install GIT in both platforms, Linux and Windows, right? Let's start, guys. Let me launch two instances. Just name as EC2. So guys, it's Linux one. First of all, update the machine. So then install a GIT apt to install GIT, something like this. So here guys, the installation is pretty simple guys. Just one command and we can install this. Now you see here guys. You see here is the command to install Git. Now I see the installation on Windows machine, right? Let me launch one Windows machine. So here guys, let me connect Windows machine. So here guys, let's download GIT. Before download, enable group policy settings guys here. Right? So let's see how to configure group policy. Say go to local group policy guys. There what you can do is local policies, security options. Here you see number of security options here. Say here there's option known as let's come down. You can see the option over here. User account control admin approver. This one. Just enable this. This one is enabled. Then guys, what you can do is just close this one. Let's go here guys. A local server. Here you see there's option here guys. Enhance security configuration. This one better you off it. Right? Just off this. Say okay. The further guys, one more thing. Say go to your browser. Internet options. Say confirm the file downloading is enabled or disabled. So what you can do is just say security, custom settings. Try to find file download here. Say downloads, it should be enabled. Say okay. So guys, let me download the Chrome or whatever software. Try to access. See, you can download this. So likewise, you can download any softwares. Before that, configure the group policy settings as it is. So you set as default, say go with this. Now guys, we have configured like say you can use this browser. Just access any sites. So here guys, start to download Git. Say download Git for Windows machines. Just go for the first link. Okay, let me go for other. Let's see what does this says. Yes, this one does. Here you have a number of options here, guys. The downloading option. Go for Windows. Now you have two flavors here, guys. One is 32-bit, other one 64-bit. First of all, check the OS bit. Say what you can do is go here, just search, just type DIAG. There you can confirm your OS bit. Okay, now there's a result comes here, guys. Here you just see here, guys. Windows Server 2012R2 64-bit, guys. This is the this one is 64-bit OS. So what you can do is, guys, just download this one. The second option, right? Download and install. Then you install this one. Say additional icons on the desktop, something like this. So let's just finish it off. Now just say skip this option. Now go and check whether it has been downloaded or not. So just close this one, go to the desktop, and here you see a Git bash. Just run this. You can see it's a Git bash. Say whatever commands whatever commands you run in Linux, same command you can use here as well. Okay. So this is the installation part of this class. Okay. Okay, guys. Install in Linux computer and Windows computers, right? Both computers we install. And say what is GIT? It's a global information tracker, right? That is known as GIT, guys, right? Say GIT. Say what is GIT, guys? Global information tracker, right? There is a GIT. DevOps, we need GIT, guys, right? Say where the developer is going to upload their code, right? Say, guys, this is the GIT or GitHub. GIT is installed your computer. GitHub is a global repository. Yeah? Git or GitHub, right? Where the developer is going to upload the code, right? The development team or the developer uploads the codes here, right? Inside Git or GitHub, right? Now see how the Git works, right? Say once the developer upload the code, right? There's another tool known as Jenkins, right? Jenkins is going to get the code from GitHub, a repository. Yeah? The wording is very important, guys. A repository, right? Jenkins is going to get the code from the repository, right? Then it will do the balance part, right? Right? Today we are going to focus on Git and GitHub, right? This is the development team. Say let's be dev team. Say once they upload the code to GitHub, right? Anyone can access the code. Say other person is from Canada, he can access the code. Maybe other person is from India, he can access the code, right? Anyone can access the code from GitHub, right? It may be the public GitHub, maybe the private GitHub, right? Anyone can access the public GitHub, okay? You know this one, GitHub. Just go to Google and find the GitHub. This is the GitHub, guys. This is a global repository, right? Anyone can create the account here. Go here and create the free account. Then you upload your code. Okay. It may be a public repository, maybe the private repository, right? Anyone can access this code from global. Here, I have created account in GitHub and logged in, right? Logged in. Right? Then you can upload the code global, right? So last class, we have installed these things Git in Windows computer and Linux computer, guys. You can use any of the computers to work Git, right? Say guys, say first of all, let me go with these things, right? Let me go with Git, then we will discuss about GitHub, right? Right. See, when you create Git, okay, it should be inside the folder. It should be inside the folder. Say, let's see, the folder name is NetXperts. Inside folder, Git is there. Git is there. Git is a hidden folder. So it should start from dot, is hidden folder. Inside Git, we have some other tools. Tools are inside the Git folder. We have some tools, right? Say by using this tool, Git is going to manage the files. Where do we have our files, guys? The files are here. Here we are going to deploy our files. Say files. Git is going to manage file, not folders, guys. Right? Say other point here. The Git is going to manage files, not folders, right? say Git is a repository. A repository means it is going to manage some file version. Okay. The backup is different. A repository is different, guys. Very important. What is backup? Backup means you create a folder and always copy the particular files or just update the files to get the backup. But Git also kind of backup, but it's not backup. Okay, so it has the revision numbers, version numbers, the branches, right? Those things comes. That's what a Git known as the repository, guys. Right? Repository. Right. Right? Is a repository, yeah. So, if you want to create the Git, you go to the Linux prompt and just type Git init. Git init. Initiate the Git, right? Say, let me create a folder here. Create a folder. Go to the folder. Right. Now we are inside the folder. Say ls and z, nothing is there. I'll say ls minus a and c, nothing is there. That means there is no Git initiated. So if you would like to initiate the Git, guys, just go and say, just say Git init, initialize the Git, right? Last we already installed Git. How to install Git, guys? apt install Git. We already done last class, right? Today we are going to install Git. Say, what is the command? Git init. Right? Just enter. You get some message like this. Okay, right? Just type ls minus a and c, right? If you type minus a, you get all the hidden files and folders. Enter. Here Git is there. That's what I told you. Say NetXperts is a folder. Inside there's another hidden folder known as Git. Inside Git there are some tools there to manage the files. Where we are going to copy the files, where we are going to create the coding. Here, somewhere here in this space, not inside the Git folder. In this space, we are going to create our coding. Developer is going to create the code in this space, guys. Say in this space, he is going to create the code, not Git folder. If you go to Git folder, you can see some tools. Say cd Git. Say you can see some tools. Okay. Git uses this tool to manage the file. Right? Git, guys, uses the tool to manage these files. The files are somewhere here, right? Say cd double dot, right? ls, right? Right? Now you may ask the question, who found this software, Git software? Linus Torvalds, he is the one found this software. Okay. Say, you know, this is the person who found this software, guys. Linus Torvalds. This is the person who found the software, right? So he is the one found the Linux kernel, right? He is the one found the Linux kernel. The same guy found the GIT as well, right? GIT as well. He is a founder of GIT. There are many version control system, guys. GIT is a version control system. Other one is a Bitbucket is there. Code commit is there, right? Likewise, there are different version control system, right? Among this version control system, GIT is a famous one. It's an open source, guys. Further, it has some facilities like staging, right? It has some facilities like staging and all, right? Say, let me show you something. Say, it has some facilities like staging, guys. The staging facility is not available other version control system like Bitbucket, code commit, right? Say, there are some example for the version control system. Let me put some example for this one. Version control system. Say one is GIT is there. Other one is a bit Bitbucket is there. Other one is code commit is there. Among these one, this is the famous one, guys. So if you know these things, you can able to manage these two things, Bitbucket and code commit, right? You can able to manage. Right here, this is the GIT architecture. See the working area is there. What is the working area, guys? This is the working area. Here we are going to run some commands, guys. Right? Say, right? This is the local repository. Local repository means we are going to store the files in this computer, in this machine. Other one is the remote repository. Yeah, say GitHub is a remote repository, right? Say GitHub is a remote repository, guys. This is the remote repository, right? Here you can pull the code, you can push the code. Developer pull the code, developer push the code, other developer pull the code, pull and push, right? This is the architecture of GIT architecture, guys. Right? Let me get one coding. Let me get one these things. One coding. Say, let me get one HTML or whatever coding, Java or whatever, C or C plus or something. Right. Say W3 School is one of the famous website, right? Say, let me go with W3 Schools. Here you can get any coding, right? Say, let me get one HTML something. Here you can get any coding. Let me get this, let me copy and paste, right? Here, say, let me create a file here. What is the file? This is the to create the file, touch index.html. Let me open the file. So the file is the index.html. This is the HTML stuff, right? I just copied some. HTML stuff, right? Here you can see the index.html is there, right? Yeah. Let's see some background about this GIT, right? Say this is the version control system, right? You can have localized version control system. That means you can show your file locally. That means say this is your program, the version 1.1, version 1.2, version 1.3. Likewise, you can show the version, right? Say for example, right? Say let me say once I modify this file. Once I modify this file, I am going to put a version. This is the version 1. Then I am going to modify the file and put this is the version 2. Right? Git manage this versioning part. Right? So here there are some tools over here. Right? See ls-a cd.git. Here you can see some tools. These tools are going to manage the versioning and other activities. Right? These are the employees of Git. Right? Git uses these employees, right, tools to manage the functionalities. Right? Right. State one is the local version control system. Other one is there. This is the centralized version control system. Other one is there. This is the distributed version control system. Distributed means it's a GitHub. This is an example. Right? GitHub is an example for distributed version control system guys. Right? Say this is the local version control system. That means locally we can manage the version control system. Right? We can modify the file and locally manage. The thing is, guys, if the computer hard drive gone, then you can't recover these things. You can't recover the file. Right? So then they come with another concept known as centralized working control system. Here, in the central server, central repository, they put all the data, all the code, all the files, and get the working copy and work in other computers. So, for example, the developer, he get the working copy and work here. Right? The team lead, he get the working copy and work. The database admin, he get the working copy and work. Right? Here is centralized. Right? Centralized. Thing is here, they get the working copy. Right? They get the working copy and work. Developer is working, database admin is working. Right? Say, there are some drawbacks here, guys. A developer is working one of the working copy. The database administrator, he has to wait until he commit the code. Say, what do you mean by commit? Commit means the programmer is going to save the code or he is going to complete the coding. Right? That is known as committing. Right? Every day, programmers are going to commit the code, right? Committing. Say, once they commit, then they are going to update to central repository. Then database admin is going to get the particular working copy and work, right? Here they get only the working copy, not all the repository. The repository is in the central server. So anything goes wrong in the central server, then we can't recover the data. They have only the working copy. They don't have full copy. The full data, full coding is inside the server. Anything goes wrong here, then they can't access the data. They can't access the coding, right? But so then they move to a distributed version control system. Here, all these guys are getting the full copy. Say, for example, a developer is working in this machine. So he is getting the full copy. Get the full copy and dump to his computer and work. The DB admin, he get the full copy and dump to his or her computer and work, right? And DevOps guys, they get the full copy and dump to their computer and work. So anything goes wrong here, anything goes wrong, or still they have their own, they have all full copy. Okay, they have full copy, guys. Anything goes wrong here, right? Right. So that's what distributed version control system is recommended. So people recommended distributed version control system. Anything goes wrong, still they have the full copy. From the full copy, then they can restore the data, right? Here, anything goes wrong here, these guys, they lose the data, right? Here, it's not like that. Still, all these guys have full copy. Okay. Say they download the full copy to the computer and work. Here also same thing. They download the full copy and work. Here also same thing. They download the full copy and work. Once they complete the work, they push the coding. Push the coding to GitHub. If they want the code, then they pull the code to their machine. When they pull the code, all the data comes to their computer. Once they finish the work, again they are going to push it. Then the data goes to GitHub again. Right? Here they use pull and push method. So if they want to upload the data, then they use push. If they want to download the data, they use pull. Right? And this is the symbol, guys. This is the symbol of these things, Git. And GitHub, they come with the cat symbol. Right? Here they use push and pull. Right? So that's what this distributed version control system is recommend, right? The data is safe, secure, right? And anything goes wrong, we can recover the data. We just push all the data here, right? Further, all these guys able to work parallelly. The developer also work parallelly. DevOps engineer also work parallelly. Database administrator also work parallelly, right? Here it's not like this, right? Once the developer finish the work and update, then database admin, they start the work. It's like that. Okay. Right. Here, all these guys, they work parallelly and they save the time. Right? That's what this GitHub is famous guys. Right? That's what this GitHub is famous. Right. This is some background about this Git and GitHub guys. Right? Right. Let's see the Git and GitHub architecture. Right? This is the Git architecture, guys. The working area here. The staging is there. Committed is there. Then remote repository. So these two layers are inside the local repository, guys. So these two layers are here in your computer, right? This is local repository, guys. This is the remote repository. Later we'll discuss the remote part, right? This is the working area. Here, this is the working area, guys. Right? Right. I already created a file known as index.html. Right. Say once you put a file, now file is somewhere here, guys. The index.html is somewhere here. Once you put the file, index.html is somewhere here. Once you put the file here, these tools is going to access this file automatically, right? These tools are going to access this file. Right. Say, now let me run the command like this, git status index.html. Right? Let's see this index.html status. Huh? Right. Now Git is saying it's untracked files. I'm unable to track this file. There's a file is there, index.html. There's a file is there, index.html. I am unable to track these files, right? What is this file? Untracked files. No commit yet, right? It's saying something like this. I'm saying it's on master branch. First is saying the file is in master branch. Later we will discuss master branch today, right? And saying no commit. And untracked files. Say these two things, guys. What is these two things? Say this one is connected to this layer, committed layer. This one is connected to staging layer. Right? Say in your school days, guys, you get your certificates, you get the awards from a stage. You go to a stage, there you get your award, right? Or you get your certificate. Something like this, right? So we are going to give a certificate to the particular file. We get the file is somewhere here in the working area. The file is somewhere here. We are going to put the file here in the staging area. Right? That means we are going to certify, right? We are going to certify. Then we are going to commit this file. We are going to commit this file. That means locally we are going to store this file. Right? The file is somewhere here. We get the file and put it to the staging area. That means these files are ready to save. Right? We are saying these files are ready to save. Then we are saving the file. Right? We are committing the file inside the local repository. Right? Say the file is somewhere here. If you want to add this file to the staging area, right? Staging area, you have to say git add. A git add. Huh? Say here, git add index.html. Right? Say enter here. Now file is in a staging area, guys. That means ready to commit, right? Ready to save or ready to commit. Huh? Right? Say if you type git status now, enter here, you see here no commits yet. No commit yet. Changes to be committed. Changes to be committed. Ready to commit. Right? Ready to commit. See, the file is in the staging area now. File is in the staging area. Now it's saying ready to commit, right? Ready to commit, right? Say if you want to commit the file, git commit, say put -m, my first program, right? Just put I don't just put git commit, just put index.html here, right? -m. You are going to describe some. This is my first program, right? Enter here. Right? Saying something there. Saying unable to detect email address or something. Don't worry about these things, right? Okay, let me put like this. Let me put like this, huh? Right. Git commit and give the description like this and just and index.html. And it's saying blah blah things. Tell me who you are, blah blah things. It's telling something, right? Right. Say let me run this command and see, right? just give your name here, right? Say who you are, what is your email address and all, right? Say just put your name. You can give your name, right? We will discuss this commands, right? Don't worry about this. Right. Right. Say now type git status. Git status. Index.html. Right. Now say git status this one. Now saying on branch master. This is the master branch we are going to discuss later. Nothing to be commit working tree is clean. Right. So the file is in this state now. It's committed. Okay. The file is in committed. All the changes has been committed here. Right. Right. Here you are going to specifically define your name and all. Who has done these things and all? Say they use git config. They use the word global. And what is the username? Just give the username and git config global and the email address. Who has done these things and just put the particular developer email address. All right. Just give the name like this. Finally, git commit -m and give the description and index.html. So if you apply this command, guys, if you apply this command, so these files are here. It's move to somewhere here. Right? It's in the committed location. Still the file is inside the local computer. Still the file is in local computer, right? Right. Say let me go here again. Let me modify the file. Say let's say vi index.html. Just go and modify this file. Huh? Just put a tag here. My second program or something. I have done a small modification. Right, I have done a small modification. Right, now see. Now go and see the status of the file. Say how to see the status of the file. Git status index.html. Git status index.html, guys. See, I just modify the file. Now it's saying the file has been modified. Modified. Right? Again, the file is in working area, guys. Now it's saying file has been modified. Again, what we can do is put the file to the staging area. From here, we commit the file. Right? Commit means we are going to save the file locally. Right? In this computer, we are going to save the file. Right? Say git at index.html, right? Or you can type git at dot also possible, right? All the files. Right now we have only one file. Then it's okay. Git at dot or git at index.html. Enter. Now the file goes to move to staging area. Say just type git status, guys. The is in the staging area, right? The staging area. The changes to be committed. We have to commit these things. How to commit these things? Git commit, say -m. Just put a comment, and comment. Say my second program or something, right? And this is the index.html, and mention the file name. Enter here. See this one file change, one insertion. There's a insertion, right? There's no deletion. Minus is there, deletion is there, but it's not nothing to be deleted. We just add something. We just add some file, insert something, insert something, and the file got changed. One file changed, right? What is the file name? Index.html. Right. Now see. Now again type git status. The nothing to be commit, already committed. Working area is clean, and we are in the master branch. We will discuss the branches in part. Right? So we use the command, add command, the commit command, right? Blah blah blah. We just if you say git at file name, we put the file to the staging area. So these two things are, guys, virtual things. We can't see. Inside the computer, guys, inside the computer, we can't see these two things. The staging or committed, these things we can't see, right? These are the virtual things. So using this command, using this git status command, we find the location, whether it is in the staging area or whether it is in the committed area, right? Right? Say why we need this one? Why we need staging area? If you stage the file only, you can commit the file. Without stage, you can't commit the file. That's what we need the staging area. Why we need the remote repository? Say once you commit the file, you can upload to remote repository, guys. You can push it. You can push it, right? Right? You can push it. So this is the Git architecture, guys. Working area is there. The storage area known as local repository. Local repository is your hard drive, right? Local repository, guys, is your computer hard drive. This is the remote storage. This is the remote storage, right? Inside hard drive, we have two layers are there. Say one is the staging area, other one is committed area. So these things are virtual things. We can't see these things, right? Right. Right. Let me create a let me modify the file again. say PA index.html. Let me add my coding. Say, let me put H2. Right? Say save these things. Right. Now check the status of the file. Git say is saying the file has been modified. Now see, use git at the file name to update that will be committed. Right? Use git restore file to discard the changes in a working directory. If you want to remove the changes, just type git restore and the file name. You won't get the changes. Okay, there are two possibilities now, guys. Now, see, the file is in the working area. Right? You can put the file to a staging area. Staging area. Or else you can revert the changes. Again, the file back to the normal. So these are some commands. This command for this one, this activity, this command for this activity, guys. You can put this file to the staging area, or else if you apply this one, git restore the file, then all the changes what you have done now, all the changes will be removed, then the file back to normal. Right? File back to normal. There's another area is there, the commit. Right. You can able to commit as well. Say once you finish the staging part, then you can able to commit as well. Right. Now saying the file has been modified. What is the file name? Index.html. Would you like to put this to staging area or remove the changes? Let me put these things to a staging area. What is the command here? Git add. I am going to add this to staging area, right? Say index.html. Right? Now see the status of the file. Status. Right. Now say use the file has been modified. Changes to be committed. Ready to commit. Say how to commit. Git commit. Say -m. My third modification. What is the file name? Index.html. One file change, two insertion, right? So you see the plus is there, right? If you delete the file, the modify means you can add something or you can delete something. That also deletion also known as modification, right? Here we add something, we add some files. Let me modify the file again, right? Say this is the one of the coding. The programmer is modifying the file. So here, just put it to H3. Say my third modification. Just put that something. Just git git status. The file is modified. Say what you can do is git add. You can use index.html or dot, right? Right. Then say git commit -n. Just comment it. This is my fourth modification or something, and mention the file name. Right? Is also done. Right? Now we have modified the file. Right? This is the file, guys. This is our coding part. This is the developer's coding part. We modify the file. Say first time he modified, second time he modified, third time he modified, fourth time he modified. Right? And this is the latest copy. And this is the latest coding. Right? This is the latest coding. Right? Now, see. Just go in here, just type git log, right? Enter. Here, you see here, the programmer has done this much of modification. Who has done this one? What is the name? This is the name. What is his email address? At what time he has done the modification? This time. This is the second modification. This is the third. This is the fourth. This is the latest modification. And the head is pointing to the master branch. This is the latest. That's what we always get the latest modification. The reason is head always point to the latest update. Say if you cat the file and see, if you cat index.html, you get all the modification. This is my first one, second one, third one, fourth one. Likewise, you get the modification. This is the update, right? So when you cat and see, this is the file, guys. You can see the log also, right? Git log. This much of time the programmer modified the file, right? And you can see the timing and all. The log is there, right? The timing and all. And guys, this is the revision number. This is the revision number. Right? There's the algorithm known as SHA1. Okay? That is a algorithm. Prepare this revision number. See, this is the revision number for this one. There's a revision number for this one. Right? Likewise, you can see the different revision number for these changes. Say if you compare these things, there should be a different revision number. Okay? This one, there should be a different revision number, right? All are unique revision number, guys. Further, the head is pointing to the master. Let me go to the presentation. See, the head is pointing to the latest update. What is the latest update here? So finally, this is the file cat index.html. So this is the final these things. So we have done some changes here. I think last commit we didn't commit it, right? So just git a status. Anyway, we have committed, right? Committed, right? Let me add one more line, right? Let me go to the index.html. Right? Just modify it. Modify the file, h4. My fourth program. H4. Right? Save these things. Git status. Modify. Just say add these things. Send the git commit. Say my fourth modification. Index.html, right? Modify. Say git lock. You can see the lock here, right? So the file has been modified this much of time, right? So guys, see the revision number. The revision number is so big, right? So people won't like these big numbers. Sometimes hard to remember these numbers and all. So then we are going to shorten these numbers, right? So what you can do is git log -- one line, right? Now we have shortened these numbers. See, here we get the in this range, we get only the 7 characters. We get only the 7 characters, guys. Say if you type git one line, it won't give the detailed output. It gives something like this. Fill the head pointing to this one. So you can type like this. If you want to compare the changes, between this commit and this commit, what you can do is git. I would like to get the changes. What is the last change? What is the last modification? Git diff space. Just put this one first. Oh, sorry, not this one. This one and this one. Say we are going to compare the group fourth. I think actually it should be fifth. It should be fifth. Unfortunately, I put fourth. Right. Anyway, we just type these two numbers. Enter here. Right. So this is the last modification, guys. This is the line I have added finally. My fourth row. You can compare. Okay, what is the new thing from here to here? How can you compare? Compare git diff and just put the revision number. This should be first. This should be second. Right, and enter. This is the last modification done, guys. Right? Isn't it? My fourth. This is the line I have added finally. Right? My fourth. Right? You can compare the differences. Right? You can compare. Let me differentiate this commit and this commit. Let me differentiate this commit and this one. Enter here. You can say this line has been added. This line has been added here, somewhere here. You can place the full revision number. Say you can say git log. Rather go for a small portion. Enter. You can put the full revision number. That also possible. Huh? Say differentiate. I would like to get the differentiate from this commit and this commit. Right? Enter, it works. So this is the line you have added. Right? Anyway, the head always points to the last modification. Right? Last modification. See, head is pointing to the last modification. Right? Say there is a requirement here. The programmer is saying, I don't want these changes. I don't want these latest changes. I would like to go to these changes. So if you see the file here, cat index.html here, you see the file, right? The programmer is saying, I don't want this one. I would like to remove this line. So what you can do is, you can go to the file and remove the line. That is okay. Right? But if you use GIT, you have to use GIT command to remove this line. Say guys, since it's a file, anyone go to this file and remove the line. That is okay. Right? Right? The thing is, guys, since we are using GIT, we use the GIT command to remove the file. Right? We are going to remove this file using GIT command. Right? Say go to the GIT log. Right? This is the last modification. Okay. Now programmer is saying go to the this one. Right? Go to this changes. I would like to revert the particular coding to particular for the previous commit. Right? I don't want this commit. Okay, there are some issues in the coding. I would like to go to my previous commit. Right? Say what you can do is you have to say GIT to revert it, one step revert. Right? Now it's somewhere here. Say you have to say one step revert. Right? Then you get the particular coding. Right? Then you get the particular code. Again, if you revert here, then you get the previous commit. Likewise, you can revert it. Right? Let me revert and see. Right? Now see. Now see the file at index.html. I don't want this last change. Right? I have to remove this. Right. So what you can do is go to the log file. Just say GIT revert it. Right? Just revert it. Say one step back. Right. Just copy this line. Index.html. Enter here. Wait. Right. Revert. Here you mention the reason why you are reverting. Right. Here I am going to mention. I would like to mention, as per the programmer's request, I would like to revert these things. Just type something like that, right? Then say control, then say save and exit, right? Save these things, right? And right now say there's a deletion, guys. Say there's a deletion is there. The revert my fourth modification is reverted. Right? Now go and see the file now. Right? Cat index.html. Now see, the third is there. Say you can compare the file. This is the the latest file. Let's see the previous file. Let's compare this file. Compare this file. Here in this file, this line is not there. Only the MySec Pro up to third. This line is not there. It's reverted. We have reverted. Right? Right? This is how we revert these things. Right? Right? This is how we revert this. Right? So if you apply revert, this will be what happened to this one. This will be deleted, guys. This will be deleted. Now we are here. So if you want to go to this change, what is the command? GIT revert. So if you want to go here, you go here, revert here. From here, you revert here. But this is not good practice, guys. So if you want to go to particular commit, say you have to go. You have to use a reset, right? If you want to go to particular these things, you have to go to reset. Say one step back is revert. One step back, guys, is revert. Huh? So if you want to go to particular commit, just put a reset. Right? If you say reset, this will be deleted, this will be deleted, and you have this commit only, this changes only, guys. Right? Let's apply the revert and see. Now see the file, log file, git log, right? Enter here. Now there are many commits here. You see all the records here. Say 1, 2, 3, 4, 5, 6, blah, blah, things, right? So the head is pointing to this one now. The head is pointing to this one, right? Meantime, see the file. See the file cat index.html, right? This is the file, right? Just copy the file. Right? This is the current situation, current file. Right? Now there's a requirement. The programmer is saying there's a requirement to go to particular commit, right? Go to particular commit, right? Say, let's see, first go to the first commit, first commit. Right. Say, what is the command, guys? Git reset. I am resetting. I would like to go to this one. This one. This commit. Just enter the commit revision number. Commit revision number. Enter here. Right. Enter. Right. Now see unstage changes after reset. Say m index.html. Now go and see the file at index.html. Okay, it's something like this. There's no changes, huh? There's no changes. There's no changes. The still file as it is. Unstaged. Okay. Just type git checkout index.html. Updated one path from index. Now go and see the file. Copy the file and compare the file. Now you can compare the file. Here the one line is not there. We have say now. Sorry. I think. So it removed these two lines. Now we are here, right? Now we are here. You see only these two lines, right? So we have gone to particular commit, right? There are many commits here. Okay, 100 commits. Right? From here, we have gone to particular commit, right? For these things, you have to use a reset. Okay, you have to be more careful when you use reset. Use checkout as well. So first we execute this command. Git reset. Go to these things. Then you have to check out. That means refresh the file. Checkout means refresh the file. Then we have executed checkout. After that only the changes happen, guys. Say when you apply reset, apply the checkout as well, right? And you apply a reset, checkout. Right? First we reset it and check out. Then we go to the particular commit. So when you reset, this will gone, this will gone. You see only these things. Right? Clear, guys? These commands. Right? Now the head is pointing to particular line. Right? So here we use SHA protocol to generate the revision number. You see here, guys, these are the revision numbers. There should be a number for each commit. Huh? There should be a number for each commit. Right? Right? Clear, guys, this architecture? Right. So guys, if you have any questions, please raise.